Welcome to the peaceful space of sleep-friendly science, where tonight we'll gently drift back 500 million years to witness the moment life's creativity exploded, sketching the first blueprints for the animal kingdom. Let your mind drift to the quiet, ancient oceans of our planet's distant past. For an immense stretch of time, life was simple. Then, in a geological blink, a mysterious event sparked an explosion of creativity, giving rise to the most bizarre and wonderful creatures imaginable. Tonight, we explore why. Now settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1. A World Asleep. The quiet before the dawn. Come, settle in. Let the weight of your day dissolve like salt in warm water. Let your breath find its own quiet rhythm, a gentle tide rising and falling in the tranquil dark. We are about to begin a journey not across space, but through an ocean of time so deep it defies imagination. We are going back, far back, to a world that is both alien and intimately your own. Back to the very beginning of your story, of every story that has ever walked or crawled or swum upon this earth. Before we can speak of the great explosion of life, the sudden, brilliant flowering of forms, we must first understand the silence that came before it. We must visit a world that was, in its own profound way, fast asleep. Imagine, if you will, that your consciousness can drift, unmoored from your body, and float down through the layers of time. Down past the age of humans, past the reign of the dinosaurs, past the first tentative plants greening the land. Deeper and deeper you go, through 1 billion years, then 2. The clock of the cosmos unwinds, and you find yourself suspended over a younger, quieter Earth. Look down. The continents are unfamiliar, great, sleeping shapes of barren rock. There are no forests to soften their edges, no grasslands to sway in the wind. The land is naked, a canvas of stone and dust, baked by a sun that feels somehow softer, a more distant, golden glow. The air itself is a different thing. Take a breath in this ancient world and you would find it thin, alien, holding but a whisper of the oxygen that now fuels our every moment. It is an atmosphere waiting, a promise yet to be fulfilled. But it is in the oceans that the real story is unfolding, or rather, dreaming. Let yourself sink beneath the surface of this primeval sea. The water is not the vibrant, clear blue you know. It is tinged with iron, perhaps a soft, olive green, murky with dissolved minerals. It is a planetary womb, a vast, silent nursery. And it is here, in this global cradle, that life has been patiently, quietly existing for an eternity. There are no fish to dart through these waters, no crabs to scuttle across the seafloor, no whale song to echo in the deeps. The silence is absolute, a quiet so profound it is almost a sound in itself. It is the hum of a planet in a deep and patient trance. But it is not empty. Oh no, far from it. This world is teeming with life, but it is life on a scale so small, so humble, that it forms the very fabric of the world itself. Trillions upon trillions of single-celled being bacteria are here the true rulers of this planet. They are the silent majority, the invisible heartbeat of the globe. They are performing a slow, planetary alchemy, subtly changing the chemistry of the water, the composition of the air, in a process that takes hundreds of millions of years. They are the quiet architects, laying the foundation for a house they will never see. Look closer at the seafloor in the shallow, sunlit waters. You see what look like stones, but they are alive. Great, layered domes, like giant, stony mushrooms, rise from the seabed. These are stromatolites, the Earth's first cities, its first monuments. They are built not of brick or mortar, but by the patient, collective work of cyanobacteria, layer by sticky layer, over thousands of years. They are living reefs, breathing stones, trapping sediment and reaching, ever so slowly, for the light. They are the planet's first dream of structure, of community, of building something larger than the self. And as they reach for that soft, archaic sunlight, they perform a miracle. They breathe. And with every breath, they release a tiny puff of a waste gas. A poison to many of the other microbes of their time. A gas that will one day power the frantic dance of animals, but for now is just a whisper, a trace element in a world unaccustomed to its power. The gas, of course, is oxygen. They are slowly, painstakingly terraforming their own world from the inside out. They are the sleeping giants whose dreams will shape the future. Float through this world for a while. Feel its immense, unhurried pace. 1,000 of our years is but a blink here. An entire civilization, a fleeting thought. Time is measured in geology, in the slow drift of continents, in the patient layering of sediment on the ocean floor, burying the remains of countless generations of microbial life, pressing them into the rock, turning them into a library of what has been. There is a strange peace here, a tranquility born of simplicity. Life has found a stable, successful form, and it is in no rush to change. It is a world without predators and without prey. A world without fear, without haste, without the desperate, driving engine of avoidance and pursuit. There is no need for shells, for claws, for teeth. There is no need for eyes to see danger, or fins to flee from it. There is no need for a brain to process the world, because the world is, for now, a gentle, predictable place. The genetic code of life exists, the fundamental alphabet is there. But the great novels, the epic poems of biology, have not yet been written. The deep grammar of creation, the sacred sentences that could build a limb or a heart or a wing, are still unwritten, or perhaps only being whispered in the quietest corners of the cell. The potential is there, coiled up like a spring, hidden within the simple elegance of the microbial world, a blueprint for a palace, locked inside the design of a single brick. This is the world before the Cambrian, the Proterozoic Eon, an age of quiet, microbial dominion that lasted for longer than all of animal history that would follow. It is the long, slow inhale before the great exhale of creation. It is the planet holding its breath. So let your own breath be slow and deep. Feel the stillness of this ancient earth seep into your bones. It is the foundation upon which everything you are is built. A quiet, dreaming planet, unaware of the riot of creativity, the explosion of bizarre and beautiful forms, that is stirring in its deep, genetic sleep, waiting for the perfect moment to wake up. Section 2, First Whispers of Form, the Ediacaran Prelude. The world did not wake all at once. The long, silent, microbial sleep was not broken by a sudden alarm, but by a slow, gentle stirring. A dream began to ripple through the planet's deep consciousness. Before the explosion, there was a whisper. Before the great symphony, a prelude. Let us drift now into this strange and transitional time, the Ediacaran period, to witness life's first, tentative sketches of grandeur. Stay beneath the waves of that ancient sea. The water is still murky, the silence still profound. But something has changed. For billions of years, life was a thing to be seen only with a microscope. Now, for the first time, it has built itself into shapes you can see with your own eyes. Shapes that are strange, ethereal, and unlike anything alive today. They are nature's first draft of animal life, and they are beautiful in their magnificent failure. Imagine you are a fossil hunter, centuries from now, splitting open a slab of reddish sandstone from a place like the Ediacara Hills of Australia, or the misty coasts of Newfoundland. You brush away the dust of 560 million years, and there, pressed into the stone, is not a shell or a bone, but an impression, a ghostly outline, a photograph taken in water and developed in stone. What do you see? You see things that defy easy categories. Here's Dickinsonia looking for all the world like a quilted, oval bath mat. It lies flat against the muddy sea bottom, some small, some growing to be over a meter long. It has no discernible mouth, no gut, no limbs, no eyes. It is a soft, ridged pancake of an organism, a living quilt that seems to have simply absorbed its nutrients from the rich microbial mat it lay upon. Imagine stroking its surface. It would feel, perhaps, like supple leather, a cool, living texture in the cold, deep water. It is a creature of pure surface area, a simple, elegant solution to the problem of being alive. Look to another stone. Here, a different ghost is imprinted. A frond-like shape called charnia. It looks like a fern, a feather, or a leaf from a tree that never existed. But this is no plant. These fossils are often found in rocks formed in water so deep that no sunlight could ever have reached them. This was no photosynthesizer. This was something else. An organism anchored to the seafloor, filter feeding in the perpetual dark like a strange, skeletal feather planted in the abyss, swaying gently in currents that no one was there to see. It is a paradox, a life form that looks like it belongs in the sun but thrived in the night of the deep ocean. They are everywhere, these phantoms. Discs, tubes, branching fronds, and segmented experimental forms. They are the Ediacaran biota. The first time life decided to become big. But it did so in a way that seems alien to us. It built itself according to a different geometry, a different set of rules. It tried fractal branching, it tried pneumatic, air mattress-like bodies. It was an explosion of possibilities, a wild brainstorming session written in flesh instead of on paper. And the world they inhabited was still, for the most part, a peaceful one. A garden, not a battlefield. There were no snapping jaws, no sharp claws, no piercing teeth. The primary pressures of life were not to eat and avoid being eaten, but simply to exist, to absorb, to grow. These quilted, frond-like beings were passive participants. They did not chase, they did not flee. They were living tapestries, drinking in the thin soup of nutrients offered by the sea, or lying upon their food source like a sentient blanket. The world was soft. Life was soft. But, in the quiet corners of this gentle world, a new idea was taking root. A subtle yet revolutionary shift was beginning. Among the strange impressions in the rock we find traces. Not just the outline of a body, but the path it left behind. We find the fossilized trails of an organism called Cambrian. It was a slug-like creature, perhaps with a hardened cap-like shell. And most importantly, we believe it had a proboscis, a sort of flexible snout that it used to graze on the microbial mats, scraping them from the seafloor. Pause for a moment and feel the weight of that. For the first time, we see evidence not just of being, but of doing. Of moving with intent. Of actively seeking out food. This was not the passive absorption of Dickinsonia or the gentle filtering of Charnia. This was a search. The very first search. And with that simple act of grazing, of moving across the seafloor in pursuit of a meal, a new dynamic was born. The ancient peace was being disturbed by the first pangs of hunger, the first stirrings of desire. The relationship between organisms was changing. It was no longer just about coexisting. A new story was beginning to be told. The story of the consumer and the consumed. It was a quiet revolution, but it would set the stage for everything to come. The first hint of predation, the first hint of avoidance. The first reason to perhaps develop a tougher skin, or a way to move a little faster. These Ediacaran creatures, these beautiful, strange first thoughts, held sway over the planet for tens of millions of years. They were a successful experiment. And then, they were gone. As you drift forward in time toward the boundary of the next great age, their forms become rarer and rarer in the fossil record. Like a dream that fades upon waking, their ghostly imprints vanish from the stone. Their chapter closed softly, silently. Why? We don't fully know. Perhaps the world changed around them in ways they couldn't adapt to. Perhaps their soft, gentle way of life was no match for the new, more active, more aggressive life forms that were beginning to emerge. They were a magnificent prelude, a gallery of beautiful possibilities. But most of them were evolutionary dead ends. Their unique body plans, their quilted geometry would not be the future. They were the trial run, the dress rehearsal. The stage was now empty, cleared of its first cast of characters. The silence returned, but it was a different kind of silence now. It was not the silence of sleep, but the silence of anticipation. The charged, electric quiet before the curtain rises on the main event. What could possibly follow such a strange and silent prelude? What spark could ignite the fire that was to come? Section 3. A breath of new air. The Cambrian trigger. That empty stage, left bare by the fading of the soft-bodied Ediacarans, did not remain empty for long. The quiet did not last. But the force that would finally ignite the riot of creation was not, itself, a creature. It was not a new plan or a new ambition. It was something far more fundamental. It was a change in the very chemistry of the world. It was a gift delivered over eons by the humblest of life forms. It was a breath of new air. Let your mind drift back into that deep, sunless water. Feel the immense pressure, the cold stillness. For 1 billion years, this world has been running on low power. Life has been making do, surviving on the faintest wisps of energy through chemical pathways that are clever but inefficient. It's like a world lit by candlelight, beautiful and subtle, but incapable of supporting great, energetic works. Life was in a state of permanent energy conservation. The Ediacaran giants were large, yes, but they were passive, their metabolism a slow, smoldering burn, just enough to maintain their simple existence. To move, to hunt, to build, to think, these things require a roaring fire. And that fire requires a special kind of fuel. The gift, as we have said, was oxygen. The patient work of the cyanobacteria, those microbial architects, had been slowly, almost imperceptibly, pumping this potent gas into the atmosphere and the oceans for over 1 billion years. For much of that time, the Earth itself soaked it up, a great, geological sponge. Iron in the seawater rusted and fell to the ocean floor, forming vast banded iron formations, the planet literally blushing with this new atmospheric chemistry. But eventually, the sponge became saturated. The planet could hold no more. The oxygen had nowhere to go but into the water itself, and from there into the thin air above. Now, another great pulse was occurring. Perhaps the breakup of an ancient supercontinent changed ocean currents. Perhaps a great burial of organic carbon prevented it from decaying and using up oxygen. And most poetically, perhaps the end of a colossal ice age, a snowball Earth that had held the planet in its grip, was the final trigger. Imagine colossal glaciers, miles thick, grinding the barren continents down for millions of years, pulverizing rock into a fine, nutrient-rich dust. And when the world finally warmed, when these glaciers melted in a cataclysmic, planet-wide thaw, all of that dust, a feast of minerals, was washed into the seas. A banquet of phosphorus and other vital nutrients delivered all at once. This planetary fertilization turned the surface of the oceans into a thriving, green pasture of algae and plankton. And what did these tiny life forms do? They photosynthesized. They breathed in sunlight and breathed out life's most powerful elixir, more and more oxygen. The candlelit world was about to be floodlit. The slow, smoldering ember was about to be fanned into a forge. This rising tide of oxygen changed everything. It was not just a gas, it was a key unlocking a door that had been closed for 3 billion years. A door to a new kind of existence. First, it offered pure, unadulterated energy. An oxygen-fueled metabolism is nearly 20 times more efficient than an anaerobic one. Suddenly, life had access to a vast reserve of power. It was like discovering fire or electricity. This new energy could be spent on things, on new activities, on moving faster than a gentle glide, on actively pursuing food rather than passively absorbing it. It could be spent on escaping, on digging, on climbing. The world was no longer just a place to exist, it was a place to act. This new energy was the currency that would pay for the Cambrian arms race that was to come. But perhaps even more profoundly, oxygen was a building material. Or rather, it was the essential ingredient for life's most important building material. Imagine the cells of your own body. What holds them together? What gives your skin its firmness, your tissues their structure? It is a miraculous protein, a molecular rope, a biological glue called collagen. It is the most abundant protein in your body, the scaffolding of your very being. It is the thread that weaves single cells into a complex animal. And here is the secret: to synthesize collagen, to weave this vital thread, a cell needs molecular oxygen. Let that sink in. Without a certain level of oxygen in the environment, you simply cannot build a complex, multicelled animal. You can have a microbial mat. You can have a simple sponge. You might even manage a strange, flat, quilted creature like Dickinsonia. But you cannot build a body with structure, with depth, with specialized tissues and organs held together in a coherent whole. The soft, gentle Ediacarans were perhaps living right at the very edge of what was possible in a low-oxygen world. They were beautiful, but they were chemically constrained. They couldn't build up, only out. The rising oxygen levels lifted that constraint. The chemical shackles were broken. Life was now free to use its ancient genetic knowledge to build in 3 dimensions. The glue was now available in abundance. The mortar was finally delivered to the construction site. And it wasn't just oxygen. That great melting of the glaciers, that mineral feast, also washed immense quantities of calcium into the seas. Calcium, the very element that life would use to build its first skeletons, its first shells, its first teeth. So picture the scene. The stage is no longer empty. It has been transformed. The water is now charged with a potent, energy-giving gas. The very chemistry of the ocean now permits, even encourages, the construction of complex bodies. And the water is saturated with the raw mineral ingredients for armor and for skeletons. The forge is hot. The fuel is abundant. The raw materials are piled high. The physical and chemical barriers that had kept life small and soft and slow for billions of years have dissolved away. A great potential, long held in check, is about to be unleashed. The world has taken a deep, oxygen-rich breath and is holding it, just for a moment, before the great act of creation begins. The planet is poised. The sea is a charged cauldron of possibility, waiting for the instruction manual, waiting for the blueprint that would tell it how to assemble all this new energy and all these new materials into the 1,000 new and bizarre and wonderful forms that we're dreaming, just on the edge of reality. Section 4. Unlocking the Code. The Genetic Toolbox. The stage was set. The environment was primed. The air was charged, the water rich with the building blocks of life. But a stage, no matter how perfectly lit, is just an empty space without actors. And raw materials, no matter how abundant, are just a pile of bricks without a blueprint. The final, and perhaps most miraculous, piece of the puzzle was not in the water or the air, but hidden deep within the cell itself. It was the unlocking of a genetic treasure chest, an ancient library of instructions that had been waiting patiently for its moment. To understand this, let us leave the vast, planetary scale for a moment and shrink ourselves down. Down, past the size of a grain of sand, past the size of a cell, until we are floating in the intricate, molecular cosmos of the nucleus. Here, coiled in breathtaking complexity, is the DNA, the scripture of life. A thread of information so long it could stretch from your hand to the sun and back hundreds of times. For billions of years, this scripture contained the basic instructions for life. How to be a bacterium, how to be an alga. Simple, elegant, successful recipes. But hidden within that same library, new chapters were being written, edited, and refined. Evolution is not just about competition and survival. It is also a relentless tinkerer, a tireless editor, working in the quiet of the genome. Over hundreds of millions of years, in the lineage of organisms that would eventually lead to animals, a new set of genes had been slowly accumulating. They weren't being used to their full potential yet, like a set of master craftsman's tools lying dormant in a workshop, waiting for the power to be switched on. These were the homeobox genes, or more specifically, the Hox genes. There is a poetry to their function that is almost impossible to overstate. Think of them not as genes that code for one thing like the color of an eye or the shape of a wing. Think of them instead as master conductors, as architects of the body. A Hox gene doesn't say build a leg. A Hox gene says on this segment of the body here is where the build a leg program should be activated. They are the genes that lay out the entire body plan. They are the grand organizers, the maestros of anatomy. They work in a beautiful sequential cascade. Along the chromosome, these genes are lined up in the same order that they are activated along the developing embryo. The first Hox gene in the sequence says, "This is the front," and it switches on the genetic programs for making a head and a mouth. The next gene in line says, "This is the segment just behind the head," and it controls the identity of that region. And so on, down the body, a beautiful collinear map from the DNA to the physical form of the animal. This genetic system is the reason you have a head at the top and a spine running down your back, and not the other way around. It's why your arms grow from your shoulders and not your hips. It is the deep grammar of biology, the fundamental syntax that dictates where to put the nouns and verbs of anatomy. Before the Cambrian, this genetic toolkit was already in place. We know this because even the simplest of animals today, like sponges and jellyfish, have primitive versions of these genes. The tools were there. The potential to create a complex, segmented body with a distinct head, middle, and tail was written into the code. But in a world without excess oxygen, without the chemical permission to build complex bodies, this toolkit was like having the blueprints for a cathedral but only having enough mud and straw to build a hut. Now, with the sudden influx of oxygen and the new energetic possibilities, it was as if someone threw a switch. The power came on in the workshop. The master craftsman, the Hox genes, could finally go to work. And what's more, evolution had been playing with this toolkit. It had been duplicating the genes. Imagine a craftsman who has only one master key. He can build one kind of simple house. But what if one day he finds he has two keys? He can keep one for the original house plan, but he is now free to modify the second key, to file it down, to change its shape, to see if it can open a new kind of lock, to build a different kind of room. This is what happened with the Hox genes. They were duplicated. And once there was a spare copy, evolution was free to tinker with it. One copy could maintain the essential original function while the duplicate was free to mutate and evolve a new one. Build a simple appendage could now become, with a few tweaks, build a feathery gill, or build a walking leg, or build a grasping claw. The explosion of life in the Cambrian was not, therefore, about the sudden invention of brand new genes from scratch. That would be like trying to write a new dictionary overnight. No, it was about the creative use and repurposing of a genetic toolkit that had been slowly and patiently assembled over the preceding eons. It was a revolution in regulation. A new way of reading the old books. The new, oxygen-rich environment gave life the permission to be complex. The Hox gene toolkit gave life the instructions on how to be complex. Suddenly, the silent, dreamlike potential within the DNA could be expressed in the physical world. The abstract concept of front and back could be realized in flesh. The instructions for segmentation could now build an arthropod with its jointed legs and external skeleton. The plans for a nervous system could now be laid out along a body axis, concentrating in a cluster of ganglia at the front, the first faint glimmer of a brain. This is the beautiful dance between the environment and the gene. They are partners in the creation of form. The world outside poses a question, and the code within whispers a possible answer. For hundreds of millions of years, the world had asked, "Can you survive?" and the genes answered with simple microbial resilience. Now, the world was asking a new set of questions. Can you move? Can you see? Can you hunt? Can you hide? Can you build? And for the first time, the deep grammar of the Hox genes, empowered by the fire of oxygen, allowed the genome to answer with a resounding, and suddenly very loud, yes. The blueprint was unlocked. The architects were at their drafting tables. The world was about to be populated with their creations. Section 5, the first eyes open. An arms race of senses. The stage is set, the blueprints are open, the forge is lit. Now the play begins. And the plot, which had been a slow, meandering pastoral for 3 billion years, suddenly becomes a thriller. The central engine of this new plot, the driving force that would accelerate evolution at a terrifying, breathtaking pace, was a simple yet world-altering feedback loop, the relationship between the hunter and the hunted. Let us return to the Cambrian seafloor. It is no longer a gentle, passive garden. With the new energy and the new genetic instructions, life has learned to move with purpose. And the most powerful purpose of all is to find food. We saw the first hints of this with Cambrian, the grazer. But now, this simple act has been taken to its logical and most dramatic conclusion. The first true predators have arrived. And with the arrival of the first predator, the world changed forever. A new and terrible pressure was introduced into the fabric of existence, fear. For the first time, one life form became a mortal threat to another. The gentle garden of the Ediacarans was now a battlefield. This was not a gradual change. It was a flip of a switch. One moment, the world is a place of passive competition for space and nutrients. The next, it is a place of active, violent consumption. This new dynamic created what we call an evolutionary arms race. It is a self-perpetuating cycle of innovation, a dance of escalating stakes. A predator develops a slightly better way to catch its prey, perhaps a stronger grasping appendage, a mouth part that can pierce. The prey that survives is the prey that, by random chance, has a slightly better defensia, tougher skin, the ability to burrow a little faster. These survivors pass on their advantageous traits. The next generation of prey is, on average, a little tougher to catch. This, in turn, puts pressure back on the predator population. Only the predators that can overcome this new defense will eat and reproduce. And so it goes, a relentless, escalating spiral of adaptation and counter-adaptation. Attack, defense. Shield, sword. Armor, armor piercer. This is the engine that drove the Cambrian explosion. It was a biological world war, and it forced life to become creative in ways it had never been before. And what was the single most revolutionary weapon in this new war? It was the ability to see. Before this moment, the world was experienced through touch and chemistry. Life could feel the currents, it could taste the presence of food or toxins in the water. But it was a world without images, a world without distance. Everything was immediate, a blur of proximal sensations. Now, imagine the first creature to evolve a true image-forming eye. It doesn't have to be complex. Perhaps it's just a small cup of light-sensitive cells, a patch of pigment that can tell the difference not just between light and dark, but between the shape of a rock and the shape of a moving creature. In a world where nothing else can see, this is a superpower of unimaginable advantage. Suddenly, the world leaps into focus. Distance is no longer an abstract concept, it is a measurable reality. For the predator, the world is no longer a blind search for a random encounter. It can now see its meal from afar. It can judge distance and speed. It can plan an attack. It transforms the hunter from a fumbler in the dark into a guided missile. But the effect on the prey is even more profound. For the first time, you can see danger coming. You are no longer blissfully unaware until the moment of contact. You are granted the terrible gift of foresight. You see the shadow of the hunter approaching. And with that perception comes the desperate, driving need to do something about it. The evolution of sight was like throwing gasoline on the fire of the arms race. It forced an explosion of defenses. If you can be seen, you must hide. And so, creatures began to burrow into the mud, creating a new, three-dimensional ecosystem beneath the seafloor. If you can be seen, you must protect yourself. And so, with the abundance of calcium in the water, life began to build armor. The first hard shells appeared, a direct response to the threat of being seen and eaten. The trilobite, with its intricate, calcified exoskeleton, is the perfect icon of this new, armored world. A living tank crawling across the seafloor. If you can be seen, you must be able to escape. And so, fins and tails became more powerful, muscles became stronger, nervous systems became faster, all in the service of a quick getaway. And the eyes themselves became weapons in the arms race. Predator eyes became sharper, more acute, capable of detecting the slightest movement. Prey eyes evolved to be on the sides of the head, granting a wider, panoramic view to watch for threats from all directions. The compound eyes of a trilobite, with their dozens or even hundreds of individual calcite lenses, are one of nature's first and most beautiful optical achievements. They were windows onto a world that had, just a moment before in geological time, been entirely invisible. This single innovation vision rippled through the entire ecosystem, creating a cascade of consequences. It drove the evolution of camouflage, of warning coloration, of complex escape behaviors. It favored the development of bigger, more sophisticated brains to process all of this new visual information. A brain is an expensive organ to run, but in a world of sight and predation, it is the best investment an animal can make. So, when you see a deer freeze in your headlights, you are seeing a ghost of the Cambrian. You are witnessing a behavior born in the terror of those first ancient seas, when the first shadow of a predator fell upon the first seeing eye of its prey. Every act of pursuit and evasion in the modern world is an echo of this primal scene. The Cambrian world was not just an explosion of forms. It was an explosion of perception, an explosion of awareness. Life had opened its eyes, and in doing so, it had created a new world, a world of shimmering light and threatening shadows, a world of terrible beauty and magnificent fear, a world that was suddenly and irrevocably awake. Section 6, A Window in Stone. The Burgess Shale. But how? How can we possibly know these details? How can we speak of the glint in a predator's eye or the terror of its prey from a distance of 500 million years? The story of life is written in a book of stone, but most of its pages are illegible, smudged by time, or they tell only a partial story, the story of the hard parts, the shells and bones that are durable enough to survive their long sleep in the earth. The soft, fleshy, secret lives of ancient creatures are usually lost forever, dissolving back into the water and dust, leaving no ghost behind. Usually, but not always. Every so often in the great lottery of geology, a perfect ticket is drawn. A moment in time is captured with such startling clarity that it feels like a miracle. A window is opened not just onto the skeletons of the past, but onto its soul. To find this window, we must travel. Let your mind drift now to a specific place on the globe, high in the Canadian Rockies. Imagine yourself there today. You are standing on a narrow ledge on the side of a mountain. The air is thin and cold, biting at your cheeks. All around you, colossal peaks of gray and brown rock claw at a brilliant blue sky. A glacier, a river of ancient ice, gleams white in a distant valley. It is a world of immense, silent, geological power. A world of stone and sky. It feels like the very roof of the world. Now let us perform our magic again. Let us wind back the clock. Not just 1,000 years or 1,000,000, but 505 million years. As the timeline spools backward, a great transformation happens. The mighty mountains around you soften. They flatten. They sink beneath the waves of a warm, shallow, tropical sea teeming with life. The cold, thin air becomes a warm, dense water humming with activity. You are no longer on a mountain ledge, but at the bottom of the Cambrian Ocean, near the edge of a great, underwater cliff made of limestone. Below you, the seabed slopes away into darkness. Above you, the water shimmers with a soft, filtered light. And here, in the sun-dappled world, is the vibrant, dangerous, and utterly bizarre drama we have been speaking of. Strange creatures scuttle, swim, and crawl through the water and across the muddy bottom. The arms race is in full swing. And then, something happens. From the top of the great limestone reef above, a section of the seafloor becomes unstable. It gives way, and a river of fine mud, a dense, silty cloud, begins to flow down the underwater slope. It is not a violent, churning avalanche, but a swift, silent, suffocating blanket. It flows down into the basin at the foot of the cliff, carrying with it a perfect cross-section of the community living there. The creatures caught in this flow, the predators, the prey, the burrowers, the swimmers, are buried instantly. They are pressed into a tomb of fine-grained mud, deprived of oxygen, the very element that had given them their vibrant life. And in this airless tomb, the normal processes of decay are halted. The bacteria that would normally feast on soft tissue cannot survive. The scavengers cannot reach them. They are sealed away from the world. In this moment of sudden burial, they are frozen in time. Their soft parts, their delicate gills, their branching antennae, their guts still holding their last meal, are all preserved. The mud presses in around them, creating a perfect mold, a three-dimensional impression of their final moment. It is a photograph taken in silt, a sculpture cast in clay. It is the Pompeii of the Cambrian period. Now let the clock run forward again. The sea vanishes. The soft mud, layer after layer, is buried deeper and deeper. The immense pressure of the rock above and the slow heat of the earth cook it, transforming it from mud into a dark, layered stone called shale. And then geological forces of unimaginable power begin to buckle and fold the earth's crust. The ancient seafloor is lifted up, pushed skyward, mile after mile, until it becomes the magnificent, cold mountainside where we began our journey. And there it rested, this frozen library of life, for 500 million years, waiting. Until one day, in the summer of 1909, a man named Charles Doolittle Walcott, a paleontologist, was riding his horse along one of these high mountain trails. A loose slab of shale had fallen, blocking the path. He dismounted to clear it, and as he did, his practiced eye caught something on the surface of the dark rock. A strange, intricate fossil. He knew instantly it was something special. He had found the window. He had stumbled upon the lost library. He had found the Burgess Shale. Imagine him in the days and years that followed, high on that lonely mountain quarry. The patient, rhythmic tap-tap-tap of his hammer. Each strike splits a slab of shale, opening it like the page of a book that has been sealed for 500 million years. And on each page, a new revelation. A new, impossible creature. These were not the familiar shapes of trilobites he was used to. These were phantoms. Dark, carbonaceous films on the gray stone, like ink stains, but with the ghostly outlines of legs, of spines, of feathery tentacles, of bulbous eyes on stalks. He was seeing the unseeable, the soft bodies, the secret anatomy of the Cambrian. He was the first human being in history to gaze upon these forms. He packed them up, tens of thousands of them, and brought them down from the mountain. He was looking at a complete ecosystem. He had found the predators with their fearsome claws, and he had found the armored prey, some with their guts pierced, evidence of a successful hunt. He had found the burrowers in their tunnels and the swimmers frozen mid-stroke. It was a perfect, terrible, beautiful snapshot. A single, catastrophic moment that became an eternal gift to our understanding. The Burgess Shale and other similar fossil sites since discovered in places like China and Greenland are our portholes into this lost world. They are the reason our story can be so rich, so detailed. They provide the characters, the cast of a drama that would otherwise be entirely lost to time. They are a reminder that the story of life is not just one of grand, sweeping principles, but of individual lives lived and lost in a world as real and as vivid as our own. The stone holds their memory. It holds their forms. It has kept its silent vigil, waiting for us to learn how to read its pages. And now, with the patience of a fossil hunter, let us lean closer to that window. Let us gently take one of those pages of shale and really look at the faces of the creatures who stare back at us from across the abyss of time. Section 7, Nature's First Drafts. Portraits of the Bizarre. Lean closer to that window of stone. Let your gaze soften and your imagination take flight. The dark smudges on the gray shale begin to resolve, to take on form, to breathe with a life that has been suspended for an unimaginable time. We are about to meet the inhabitants of the Cambrian Sea. Do not expect the familiar. These are not creatures from our world. They are aliens from the deep past, experiments from a time when the rules of biology were still being written. They are nature's first drafts, and they are gloriously, wonderfully strange. Look here at this small, unassuming fossil. It is barely a few centimeters long. At first, it looks like a chaotic jumble of lines. But as you look closer, a body resolves itself. It is a creature so bizarre, so confounding that when scientists first reconstructed it, they could not make sense of it. They named it hallucigenia as if it were a phantom born of a fever dream. Imagine it. A worm-like body, but from its back sprouts 7 pairs of long, sharp, needle-like spines like stilts made of daggers. It seems to be walking on these rigid spines. And from its other side, what must be its top, are 7 pairs of delicate, waving tentacles, each ending in a tiny, pincer-like tip. What purpose could they serve? Were they for feeding, for grasping, for sensing the water? And for decades, scientists puzzled over its head. There was no head, just a shapeless blob at one end. Only recently, with more powerful microscopes, did we find a tiny, simple head with a pair of simple eyes and a ring of teeth in its throat. We had it upside down and backwards for years. Imagine this little creature, this walking paradox, teetering across the seafloor on its defensive stilts, its delicate tentacles reaching up into the water to filter out tiny particles of food. It is a creature born of the tension between defense and sustenance, a living embodiment of the new, dangerous world it inhabited. Now let your eyes drift to another page of the stone book. A larger form is pressed into the shale here. 5 large, round eyes on short, flexible stalks cluster at the front of a segmented body. 5 eyes. Not 2, not 4. 5. A number that feels wrong, alien. And from the front of this creature, where a mouth should be, there is instead a long, flexible nozzle like a vacuum cleaner hose. And at the very end of this nozzle is a grasping claw, ringed with sharp spines, that opens and closes like a jaw at the end of a tube. This is Opabinia. Imagine it swimming, propelling itself through the water with soft lobes on the sides of its body, its 5 eyes scanning in all directions, its bizarre feeding nozzle probing the mud for worms and other soft-bodied prey. It is a Swiss Army knife of an animal, a cobbled-together solution to the problems of seeing and eating. It is so strange that when its discoverer first presented it at a scientific meeting, the room erupted in laughter, thinking it was a joke. But Opabinia was real. It was a successful hunter in its time, a testament to evolution's willingness to try absolutely anything. But even Opabinia would have fled from the shadow of the true king of this ancient sea. The apex predator. The great white shark of its day. Here, on a larger slab of shale, we find its scattered remains. Sometimes a great, circular mouth, lined with sharp, slicing plates. Sometimes a pair of huge, formidable grasping claws, bristling with spines. For a long time, these parts were found separately and thought to be different animals: the mouth a jellyfish, the claws the tail of a strange shrimp. It was only when a complete fossil was found that the terrifying truth was revealed. They all belonged to one creature. Anomalocaris, the abnormal shrimp. And it was enormous. Some grew to be over a meter long, a true giant in a world of thumb-sized creatures. Picture it. A sleek, segmented body propelled by undulating fins moving through the water with a sinister grace. 2 large, compound eyes on stalks gave it superb vision. And at the front, its 2 great, spiny arms reached forward, ready to snatch unsuspecting trilobites from the seafloor. It would grasp its prey, bring it to that strange, circular, nutcracker-like mouth, and crush the hard shell to get at the soft body within. Finding a trilobite fossil with a bite taken out of it is finding the aftermath of an Anomalocaris attack. It was the top of the food chain, the product of the evolutionary arms race pushed to its peak. The terror in the deep. The sheer variety is bewildering. Here is Wawaxia, a slug-like creature covered in protective scales and long, carbonite spines like a walking cathedral of daggers. Here is Pacaya, a small, ribbon-like swimmer that is profoundly important, though humble. It possesses a stiff rod along its back, a notochord. This is the precursor to a backbone. In this small, unassuming creature, we see the first faint echo of our own lineage, the very first chordate, your most ancient, recognizable ancestor in this bizarre menagerie. And look at the trilobites themselves, the most common and famous inhabitants of this age. There were thousands of species. Some were smooth and sleek, built for speed. Some were covered in ornate spines for defense. Some had huge, crescent-shaped eyes. Some had no eyes at all, having adapted to a life of burrowing in the dark mud. They were the beetles of the Cambrian, filling every available niche, a testament to the success of their basic body plan, the hard exoskeleton, the jointed legs. Take a moment to simply be in this gallery of ghosts. Feel the creative energy, the sheer, unbridled inventiveness. Life was throwing every conceivable idea at the wall of reality to see what would stick. A 5-eyed swimmer with a nozzle claw. A spiny creature on stilts. A giant, soft-bodied shrimp-like predator. This was not the careful, incremental evolution we often imagine. This was a chaotic, explosive, experimental phase. It was biology's wild youth, a time of boundless imagination before the rules became more rigid. These creatures are more than just curiosities. They are a profound lesson. They show us that the forms of life we see today, the fish, the reptile, the bird, the mammal, are not the only possible solutions. They are not the inevitable pinnacle of a long, steady march of progress. They are simply the survivors, the descendants of the few experiments that happened to work in the long run. For every body plan that made it, a dozen, 100, 1,000 others, equally wondrous and bizarre, fell by the wayside. The Burgess Shale is their tombstone, their only memorial. It is a graveyard of beautiful ideas. Section 8. Fates of the Experiments. The Great Pruning. We have stood in the gallery of ghosts. We have gazed upon the impossible forms of hallucigenia, opabinia, and their strange kin. A question, quiet and persistent, hangs in the air of this stone library. Where did they all go? Why is the world we know not teeming with five-eyed swimmers and creatures walking on stilts? If the Cambrian was such a riot of creativity, why did so many of its creations vanish, leaving not a single descendant behind? The answer is as profound as the explosion itself. The great flowering of life was followed by an equally great pruning. The story of evolution is not just one of creation, but also one of loss. It is a story of 1,000 doors opening and then, slowly, quietly, most of them closing again forever. Think of the Cambrian explosion as a master gardener in a frenzy of inspiration, planting every conceivable seed in a brand new garden. Seeds for plants with leaves of glass, with roots that sing, with flowers that taste the air. For a time, the garden is a chaotic, bewildering, magnificent jungle of possibilities. Everything is growing at once, competing for the same patch of sun, the same drop of water. But a garden left to its own devices does not remain in the state of chaotic diversity forever. Some plants are simply better suited to the soil. Some are more resilient to the changing weather. Some grow faster, casting their neighbors in shadow. Slowly, a process of natural weeding begins. The less robust designs, the beautiful but fragile ideas, begin to wither. The hardier, more efficient, or simply luckier plants thrive, spread, and begin to define the character of the garden. This is what happened in the millions of years that followed the Cambrian. The world did not stand still. The conditions that had fostered the explosion, the warm seas, the specific chemical balance began to change. Sea levels rose and fell. The climate cooled and warmed. The planet continued its slow, inexorable tectonic breathing. A body plan that was perfectly adapted for a warm, shallow, oxygen-rich sea might find itself fatally unsuited to a colder, deeper, or less oxygenated world. The rules of the game were constantly being rewritten, and not every player could adapt to the new addition. In the arms race, the engine of innovation did not stop. It only intensified. The most successful body plans like that of the arthropods with their versatile exoskeletons and jointed legs became ruthlessly efficient. They multiplied, diversified, and spread into every available niche. They became better hunters, better scavengers, better survivors. For the stranger, more experimental creatures, the world became a much harder place to make a living. It's one thing to be a slow, strange Wawaxia in a world of other slow, strange creatures. It's another thing entirely when your world is suddenly filled with fast, efficient, armored trilobites who are competing for the very same food. The competition became fiercer, and in this crucible of survival, many of the early, bizarre drafts were simply outcompeted. They were crowded out of existence. But it was not always about being better or worse. Sometimes it was simply about luck. This is one of the deepest and most humbling truths of the history of life. We like to imagine evolution as a grand, predictable ladder of progress with the fittest always, inevitably, climbing to the top. But reality is far more random, more contingent. Imagine for a moment that we could rewind the tape of life back to the Burgess Shale. And then we press play again. Would the same creatures survive? Would the same lineages flourish? Almost certainly not. A tiny change in Historia, localized extinction event caused by an underwater volcanic eruption, a slight shift in a current that wipes out a key food source, a new disease that happens to target one group and not another could have changed everything. The survival of that little swimming ribbon, Pacaya, our own distant ancestor, may not have been a grand victory of a superior design. It may have been a roll of the cosmic dice. Perhaps, in a different playing of the tape, Pacaya is wiped out by a mudslide and the lineage that leads to vertebrates is snuffed out before it can even begin. And perhaps the descendants of the five-eyed Opabinia go on to become the dominant, intelligent life on the planet, pondering the strange, two-eyed fossils of long-extinct mammals in their museums. Our own existence is a product of this profound contingency. We are here not because we were inevitable, but because our ancestors, time and time again, were lucky. We are the descendants of the survivors of a million tiny, forgotten accidents of history. And so, the great pruning occurred. The wild, experimental phase of creating entirely new body plans, what biologists call phyla, came to a close. The age of architectural invention was over. After the Cambrian, no fundamentally new ways of building an animal have ever appeared. Evolution became less of a radical inventor and more of a master craftsperson. It took the surviving blueprints, the arthropod plan, the mollusk plan, the chordate plan, and began to tinker with them, to modify them, to adapt them into an astonishing variety of forms. The arthropod plan would lead to crabs, spiders, and the billion insects that fill our world. The chordate plan would lead to fish, to amphibians, to dinosaurs, and eventually to the hand that is resting by your side right now. The wild, chaotic garden was thinned out, and in the space that was cleared, the surviving lineages grew into the mighty, branching trees of life that we know today. So when we look back at the fossils of Hallucigenia and its kin, let us not see them as failures. They were not mistakes. They were essential possibilities. They were brilliant, vibrant sparks of life that burned brightly for a time. Their silence now is not a sign of their inadequacy, but a testament to the awesome, impartial, and deeply random power of time. They are the lost poems of the Book of Life, and their absence makes the verses that remain all the more precious. Their ghosts cleared the path for our own story, and the world we inhabit was built upon the foundations of their silent, beautiful extinction. Section 9. Your Cambrian Inheritance. Echoes in our blueprint. The ghosts of the Cambrian may seem distant, their forms alien, their world lost to an ocean of time. It is easy to look at the spiny strangeness of Hallucigenia or the five-eyed Opabinia and feel a sense of disconnection, of otherness. They are curious artifacts in a museum of deep time. But what do they have to do with you, resting here, now, in the quiet of your room? The answer is everything. You are not separate from this story. You are its living, breathing continuation. You are a Cambrian creature. Within your body, within the silent, intricate workings of your cells and the very shape of your form, are the echoes, the legacies of that ancient explosion. You are a walking, thinking, dreaming museum of natural history. Let's begin with the most fundamental aspect of your being. Place a hand on your chest, then on your back. You have a front and you have a back. You have a head where your senses are concentrated and a tail, or at least the vestige of one at the base of your spine. You have a left side and a right side, a mirror image of each other. This fundamental body symmetry, bilateral symmetry, was not a given. It was an invention. A design solution that was so successful in that first great arms race that it became the dominant blueprint for almost all animals to come. The Ediacaran quilts and fronds experimented with other symmetries, radial, fractal, but the bilateral plan, with its inherent directionality, its front end for encountering the world, proved to be a winner. Every time you walk forward, you are honoring a decision made by a tiny, worm-like ancestor over 540 million years ago. Now think of your eyes. The very fact that you have eyes, that you can perceive the world in light and shadow and color, is a direct inheritance from the Cambrian. The first light-sensitive spots that gave some creature a crucial advantage in seeing a predator's shadow evolved, through that relentless arms race, into the complex, image-forming organs you are using to read these words or to see the darkness behind your eyelids. The genes that build your eyes, the opsin proteins that catch the photons of light, have an unbroken lineage that stretches all the way back to those first, world-altering windows. The terror and the triumph of that first perception are encoded in your DNA. Feel the rhythm of your breath. The oxygen you draw in is the very same fuel that powered that first explosion of life. Your mitochondria, the tiny powerhouses in every one of your cells, are performing the exact same metabolic magic that allowed the first active predators to chase their prey. The fire that was lit in the Cambrian seas now burns within you, fueling your thoughts, your dreams, your quiet rest. Think deeper into the very architecture of your body. You have a gut, a tube that runs through your body dedicated to processing the outside world for nutrients. This tube within a tube design was another Cambrian innovation, a way to efficiently digest food while the rest of the body went about its business. The simple digestive tracts of the first burrowing worms are the ancestors of your own complex internal landscape. And what of your skeleton? The hard, internal framework that gives you structure and allows you to move. It is made of calcium phosphate, a mineral that your distant ancestors learned to pull from the seawater and secrete, first perhaps as external armor, and later, in our lineage, as an internal scaffold. Your bones are a legacy of the need for defense and the need for locomotion that began in that ancient, dangerous world. Your skeleton is a hardened memory of the Cambrian arms race. Even the way you were built from a single cell to the complex being you are now is a Cambrian process. As you developed in the womb a set of master genes, the very same Hox genes that we met earlier were activated in a precise sequence. They are the architects who laid out your body plan, who whispered to your developing cells, here, make a head. Here, a spine. Here, the buds that will become arms. Here, the ones that will become legs. This genetic toolkit, this fundamental blueprint for building a bilateral animal, is perhaps the most profound inheritance of all. It is the deep grammar that connects you to the trilobite, to the fish, to the bird, and to that little ribbon swimmer, Pacaya, your great-great to the nth degree grandparent. You carry the Cambrian sea within you. The salt in your tears, the salt in your blood, is a faint echo of the chemistry of that primeval ocean. The fundamental processes of your nerves firing with sodium and potassium ions are a refined version of the systems that first allowed a creature to flinch from danger. So you see, the past is not truly past. It is not a foreign country. It is the soil in which we are rooted. The story of the Cambrian explosion is not about strange, dead creatures in a faraway time. It is the story of the assembly of the toolkit that would eventually build you. The challenges of that world to see, to move, to eat, to avoid being eaten, to build a structured body force, the innovations that are now the very definition of what it means to be an animal. You are a vessel of deep time, a living archive of solutions to ancient problems. Rest here, in this quiet moment, and feel the weight and the wonder of that inheritance. Feel the ancient symmetry in your limbs, the Cambrian fire in your breath, the ghost of a trilobite's eye behind your own. You are a masterpiece 540 million years in the making. Section 10, The River of Life. An unfolding tapestry. And so our journey through deep time brings us back to the present. Back to this quiet room, to the gentle rhythm of your own breathing. We have traveled to a world asleep, witnessed its first stirrings, and stood in awe before the sudden, brilliant dawn of animal life. We have seen the blueprints, met the bizarre first drafts, and understood why so many of them faded back into silence. And we have found their echoes, their living legacy within our very own bones. What then is the final lesson to take from this ancient explosion? What truth can we carry with us from the Cambrian Sea into the landscape of our own sleep? Perhaps it is this: the story is not over. The explosion was not an end point. It was a beginning. It was the moment the river of life, for so long a slow, meandering stream, burst its banks and carved 1,000 new channels, creating the vast, intricate delta of diversity that we now inhabit. That river is still flowing. Evolution did not stop in the Cambrian. The tinkering, the refining, the constant dance of adaptation and circumstance continues with every breath, with every birth, with every life lived and lost. The same forces that shaped Anomalocaris and the trilobites are shaping the sparrows outside your window and the microbes in your gut. Life is not a static thing, a finished monument to be admired. It is a process, a continuous, unfolding tapestry that is being woven in every moment right now. The Cambrian period teaches us that the world can change, and change radically. A shift in the chemistry of the air, a new way of seeing, a new relationship between predator and prey. These things can transform the entire planet, unlocking potentials that were dormant for eons. It is a lesson in the awesome power of interconnectedness, how the smallest of beings, the humble cyanobacteria, could, over geological time, change the destiny of the entire globe. It reminds us that seemingly small changes can have world-altering consequences. It also teaches us a profound humility. The beautiful, intricate, and successful forms of life we see today are not the result of a preordained plan. They are the survivors of a grand and brutal lottery. The history of life is a thicket of forking paths, and our own path is just one of many that could have been taken. Had a different set of creatures survived the great Cambrian pruning, the world today would be unimaginably different. There is no ultimate goal, no final destination in evolution. There is only the ceaseless, creative, and often random exploration of what is possible. And finally, the story of the Cambrian is a story of resilience. Life on Earth has endured planetary deep freezes, catastrophic impacts, and suffocating oceans. As you lie here, on the edge of sleep, feel yourself as a part of this great, flowing river. You are a cresting wave, a momentary beautiful expression of a current that runs back 500 million years to a sunlit, shallow sea. All the drama, all the terror, all the innovation of that time is part of your story. The courage of the first prey, the ambition of the first predator, the miracle of the first eye, the blueprint of the first complex body, all of it has led to this moment, to you, resting peacefully in the dark. A gentle, 200-word concluding thought. Let the ghosts of the Cambrian fade back into their seas of stone. Let the river of time flow on without you for a few hours. You have carried its legacy through your day, and now you can set it down. Sink into the deep, soft quiet that came before all the noise, the same profound peace that cradled the world when it was young and dreaming. Trust in the ancient rhythms that govern your body, the same rhythms of life and rest that have pulsed on this planet for eons. There is nothing left to do now but to surrender to the gentle tide of sleep. Let it carry you away. Let the story dissolve into dream. The world will be here when you return, a little older, a little different, but still turning, still breathing, still part of the same unfolding miracle. Good night. Sleep well.